Welcome everybody to our second webinar in the PSDI webinar series. I am Dr. Nicola Knight and I am joined today by my colleague Dr. Samantha Kanza. I will be giving a brief little introduction before I hand over to my colleague Samantha. So to start us off, I'm going to give a little bit of an introduction to PSDI. So that's not the main focus of the presentation today. So PSDI is a large-scale initiative. It's a long-term project, and the main thing is that data is a huge driver of the research in the physical sciences, but really at the moment it's quite disparate, not particularly well connected, and we could be doing a lot more with what we already have. So we're going to be researching into and developing the physical sciences data infrastructure, mainly around chemistry, materials, and related disciplines. And the aim of this really is to provide those connections, particularly across experimental and computational facilities that already are in existence, and sort of build those bridges that connect everything up. So the first webinar in this series was an introduction to PSDI. So if you want to learn more about kind of what the project is, some of the other aspects that we're working on, a webinar recording is now available on our YouTube channel. We also have lots of information on the PSDI website about the work that we've carried out in the pilot phase and also in our current work, and some of the reports and outputs that we have provided so far. Our current work that we're doing in this sort of phase is divided up into 5 different work packages. We went into a little bit more depth than the kind of general work of these in the last webinar, and I'm hoping that in future webinars we'll be able to focus more deeply on some of these areas. So the one that we are focusing on today is work package 4. So this is where we have some of the first round Pathfinder activities. So these Pathfinder activities are sort of individual elements of work that are more deeply investigating the kind of applications of where PSDI could be developed. In this phase, we have 5 first round Pathfinders. So some of these are specifically looking at the integration within a domain, such as those covering catalysis or biomolecular simulation. Some of the others look at a more generic technique that might be applicable across many domains. So these focus around the data collections and the process recording, or expertise such as machine learning. So as you will have seen from the laid slide, today we are focusing specifically on Pathfinder 2 and looking at process recording. So this is led by Dr. Samantha Kanza. So at this point, I will hand you over to Samantha. Off you go.
Thanks very much, Nikki. I feel like I should put in a little prayer to the technology gods at this point that nothing else happens. But yeah, so as Nikki said, I'm the Pathfinder lead for the process recording Pathfinder. I am a senior enterprise fellow at the University of Southampton, and I've realised somewhat, maybe depressingly or not depressingly, depending on how we look at it, I've been working in the kind of area of electron lab notebooks, digitization of scientific research, and process recording for the last 9 years. It's not necessarily felt like 9 years, but it has been quite a while. I've learned a lot in this time. Research data management, digitization of scientific research, also reuse of tools where applicable is our key research interests of mine. So I was very, very excited to come and work on this Pathfinder because it's really related to a lot of my PhD research. So let's kick this thing off. So my Pathfinder is all about process recording. So there's lots and lots of different dimensions to this, looking at the tools for process recording, how we should actually do it, the research data management aspects around it, good practice, etc. Lots of different technologies, so considering electronic lab notebooks, but also voice technologies, voice in the lab, future technologies, hybrid technologies, semantic web technologies, metadata, and I could probably talk for hours and hours on each of these subjects. So today's real focus is going to be on electron lab notebooks, paper lab notebooks, and actually capturing those processes in the lab. And just to give you a brief outline. So I'm going to talk quite a bit about kind of how ELNs and software tools have evolved over the years and what I've seen shift in the rather long 9 years I've been involved in this. I'm going to specifically talk about some of the process recording research that we've done, talk about some solutions and tools that we're working on, and then I'm going to touch on the other 6 aspects of this Pathfinder, with some information about some of the research we're planning and currently doing with that moving forward, and also some community recommendations that we put forward in our paper, which I mentioned at the end, because quite a lot of the research that's catapulted off from this Pathfinder was part of case study 6, which we did in the pilot study. Reports and such like are on the website, but this did kind of give to some particular community recommendations in each of these areas, which I think is also quite important. So let's talk about electronic lab notebooks. So very originally, electronic lab notebooks were created to serve as a direct replacement for paper lab notebooks, so that we could ensure the digital capture and retention of the scientific record. Now, to me, ELN sounded like a really obvious, good, simple solution. I come from a computer science background. I was highly intrigued to hear that, now bear in mind this was back in 2014, highly intrigued to realise that people were still using paper. What is this? We live in a digital age. Surely we use computers. What on earth is going on? And then I heard about electronic lab notebooks. Oh, this seems like a good solution. Must be quite easy to make an electronic lab notebook. Oh, you know, there's probably a few of those. Going to go have a look at them, see what all this stuff is about. And what seemed like such an obviously simple software-based solution has been anything but. And crazily, there are now over 80 active ELNs on the market with lots and lots of different approaches. So this is a pretty exhaustive list, that there might be one or two hiding elsewhere that I don't know about, but I have looked at this quite extensively, and this is insane. There is a crazy amount of ELNs. Whilst there is a lot of software for a lot of different things, you know, things like general note-taking software, word processing software, we all know the key players. There's Google, there's Apple, there's Microsoft, and depending on what you are, you use one of those, but it's pretty obvious. How on earth does one person even start to choose between these ELNs? And this is such an oversaturated market. It has so many different issues. I mean, on the one hand, it's nice to have options. And people have clearly gone for different approaches. Some support specific domains, very niche parts of domains. Some support much broader domains, or they offer themselves as kind of generic or multidisciplinary. But this is an absolute minefield. And, you know, in this sense, this isn't wildly different to what I looked at back in 2014. I think there were still over 80 on the market then. There are over 80 now. Some new ones have sprung up in that time, some have shut down or have been bought by other companies and merged into different ones. But by and large, 9 years on, we are still in a situation where there are tons and tons of ELNs. So has anything actually changed? Well, having worked in this area for quite a long time, I have noticed quite a few different shifts. So I put this little spider diagram together because I've noticed that the people stopped wanting to talk about ELNs, even though they do actually want to use some sort of digital note-taking tool. And in fact, we ourselves, when we published our paper on our research, we called it a digital research environment. I've attended a lot of conferences, also academic meetings. Both Nikki and I are part of Science and Engineering South, where a group of us universities get together and try and figure out how we can actually make some of these processes better, encourage better research data management. Some of them have actually implemented and trialed electronic lab notebooks. And everyone's been kind of calling them different things, partially because in some ways they are different things, but also partially because it's come to everyone's realization that no one actually likes the term electronic lab notebook. And if you tell them that they're going to use an electronic lab notebook, they immediately turn off and don't want to. So people are using all these different terms. I'm also finding some of these different terms in literature, but also interestingly, when I went to review all the ELNs on the market, much like I did 9 years ago, I found that things had actually shifted quite a bit in terms of what was being offered as well. So whereas it used to just be that 90% of the things I saw was just, here's our electronic lab notebook. Now we're getting entire platforms, full research platforms, digital cloud platforms, workflow environments. And they don't, a lot of them don't just offer ELNs. They offer LIMS connected to ELNs. They offer scientific data management systems. They link to registries, they link to inventories. This makes a lot of sense because actually a lot of large-scale laboratories want these big integrated environments. And indeed, some of the earlier research that Nikki and I undertook suggested that actually linking into all these different things and having one overarching platform was what people wanted. But I also think it's quite interesting because it takes the ELN out of just being, this is something that is instead of your paper lab notebook, but it is a vital part, depending on what you want to do, or at least the notebooking part is a vital part of the entire scientific research life cycle. And I think that we need to be thinking of it as such. This isn't just, I'm going to take away your paper lab notebook and give you something electronic. We need all of these different features and all of these different systems working in harmony if we're actually going to properly record our research and make it, findable, reproducible, something that somebody else can actually sift through and use. But has this actually changed anything? I mean, ultimately, we've said there were a lot of ELNs, there are still a lot of ELNs. What the companies are offering has shifted, how people are talking about them has shifted. But has this actually made any difference? So we thought that we would try and find out. We put together a process recording survey, firstly looking to find out what people are actually using. So has there been any additional uptake in ELNs? What ELNs are people using? And are they using, if not, are they using generic note-taking software? And if so, again, what? We also wanted to use this to identify areas of improvement, but also, we're looking to put together a big resource as part of PSDI to help with process recording, and figure this information would be really useful. So this is an ongoing effort. So we've had 133 responses so far. I'm reporting on the responses thus far, which do make a lot of sense with our research, but we would love to hear more from everyone else. So please do promote it, fill it in. We're going to be running it for another couple of weeks because I'm also presenting on this at ACS. So I want to give hopefully other people in other countries more of an opportunity to fill this out. But nonetheless, we have had some quite interesting results from this. So we asked people what ELNs they use. Now, again, it's not wildly shocking that over 50% aren't using them still. In fact, if anything, it's possibly more shocking that potentially over 50%, around the 50% mark, are actually using them. And you can see that there's not really a key player here, apart from potentially other using generic notebooking software. And obviously, this is not an exhaustive sample. This is 133 people. And ultimately, as much as we've sent this out to our networks of people, this is more academically based, which again makes sense because we know that ELN uptake in academia is still not fantastic. But we also then asked what needs improving. Now I'll split this up into different things: notebooking, domain-specific features, data features, and technical features. So some of the things that people wanted to improve, they wanted different input methods. I mean, this really isn't surprising. As much as I think there might be issues with using voice and other things in the lab, I do firmly believe that getting people to record things in the lab using a keyboard is a problem. And one of the reasons that people have always stayed with paper so much is because of that kind of complete ease of just being able to randomly jot something down and it not mattering if you've got gloves on. You might have chemicals on your hand, or well, on your gloves, and you can just easily grab and scroll rather than having to potentially open up programs, move things around, get back to your laptop. They want better searching and tagging, which again is not really surprising. That's one big issue, and actually something I was talking about this morning in an enabling digital tools meeting, that searching is a big deal. It's something computers can do so much better than humans, but ultimately still a lot of systems don't do it particularly well. And some other standard things like reference managing, collaboration. They want standard data features, so to be able to link between records, version control, data management. They also want some domain-specific features, which I find quite interesting because some of these domain-specific features do actually exist in ELNs. And indeed, actually, some of these technical features do. In fact, some ELNs have not necessarily everything in here, but there are definitely certain ones that have some of these features. And I often end up in conversations with people that just say, oh, I would love an ELN that does this. And I'm like, well, actually, there are a couple that do. I'm not sure if they're quite going to fit your criteria, but have you looked at? And I think that because there are so many things out there that everyone's overwhelmed, so they don't actually necessarily know that the ELNs do this, but also potentially some of that information is quite hidden in the depths of their websites or their manuals or things you can't see till you signed up. So it's obviously a little bit obfuscated. We then also asked, what generic notebooking tools do you use? So this kind of showed a lot more disparity and variation than just asking about ELNs, because people are taking notes. Again, this is something I very much found out in my PhD. We're not necessarily capturing everything. We're certainly not necessarily capturing everything that is useful. But just because people are using paper in the lab does not mean that they are not capturing certain things electronically and that they're not using software to do it. It just seems that clearly using these types of software is quite a lot more popular. I mean, potentially, I think it might also depend on the nature of the data that you're trying to capture, because having now gone through and looked at a hell of a lot of ELNs in detail, some of them don't look particularly friendly to the kind of narrative, putting down notes type entries that actually one might use something like Notepad or OneNote for. Also notably that Jupyter notebooks, we did, even though I wouldn't say it's necessarily a generic notebook, we put it in there because a lot of people use it. It's very popular. And again, I don't think it's surprising that that is one of the most popular ones. I think this is also possibly a bit Microsoft biased, because a lot of universities do have subscriptions for OneDrive and everything. So, and the fact that universities don't typically like people to use Google because it's not EEA compliant means that we might be more driven towards the Microsoft software. But again, a bigger variation here. And then we asked them, what needs improving about your notebooking tools? Now, for the eagle-eyed among you, if we just move on to the next slide, there are some overlaps in these things. So it seems like some of the things that people want to be different about their ELNs, they also want to be different about their notebooking software. It's just potentially they're more either used to the notebooking software, they're more willing to put up with it from that, or it serves the purpose they want better. But if we look in the domain specific features box, the things that people said they wanted from generic notebooking software, they also want, they wanted from ELN software, they also want from generic notebooking software, including integrate with ELN, which I thought was quite amusing. And then it like, so people are digitizing certain things. They are using notebooking software. They're not necessarily using ELN, but some of the features they want seem a bit more synonymous with ELNs. Now, obviously, you could also potentially fix that by having generic plugins, and that's definitely, or scientific-based plugins to generic notebooking software, which is something we're looking at. But that does make me think that maybe some people do actually want to use an ELN. They just don't necessarily know what's out there, what's available, or even potentially haven't thought about maybe using a combination of software tools to achieve what they want. So what does this mean? Well, I mean, obviously, we have to precursor this with, this was a small sample size and heavily academically focused, but nonetheless still shows, a lack of uptake in academia. But also, this really kind of backed up some of our previous research. So I appreciate this is quite a large figure. We will be making the slides available as well as the recording. And also there is a big version of this in the paper that we published, which I'll mention at the end. But this was a kind of collection of all the different features and all the different things that users wanted that came out of our big case study 6. And actually, again, what people said that they wanted did kind of map onto some of this. And then similarly, when we think about barriers, this also continues to back up the research that we did into the reasons why people don't necessarily want to use ELNs, why they have issues with them. We're talking hardware, software barriers. Again, we were talking about capacity to interact with the different software, data barriers. There were a lot of data things mentioned. So as much as this is a smaller sample size, it does seem to back up what we already know with some additional information. But the frustrating thing is, some of the features that users wanted they want to improve in both pieces of software, but it doesn't seem to detract from them using notebooking software. And some of the features that they want do actually exist. So what can we do? I think that one of the really big things that needs to happen is users need to know what is available. And there's been a lot of work put together to try and help people choose an ELN. People have written review articles. There was the famous Harvard Matrix. There's been information on how best to choose an ELN. Some companies have put up guides on how to choose an ELN, although some of them might be a tad biased towards their own ELN, but fair enough, that's marketing. But ultimately, these tools, these matrices, these papers, they go stale because it's done in 2019, fantastic, but we're now in 2023. Things have changed, and as much as the state of the market might not look like it's changing, people are adding new features. Actually going in and looking, it's really obvious that the offerings of these companies have changed. What's actually available has changed, and certain companies and offerings and software have come and gone. But there is now this project called ELN Finder, which we are collaborating on. So prior to the RDA meeting in March, I'd sat around and said, we really need a tool for this. There is no tool that is currently maintained that has all the different information about all the ELNs that would allow people to figure out what was actually out there. So I had in my head this grand plan. I was going to go make one. We needed this with PSDI. And then I went to the Research Data Alliance meeting and luckily stumbled upon people presenting about the very thing that I said we needed to do, ELN Finder. So this is a community-led tool, has a big database in the back end, and it has a nice metadata schema that's published. And there's 40 different criteria for picking ELNs. So far, though, they have, I think, 27. Well, they did have 27 ELNs when I started. They've now got a few more. So naturally, leaving me, I bounced over and said, we need to collaborate on this because I also want to do this. And I know about another, 50 or so ELNs. They're stupid us making competing tools. We should go in on this together. So I've been working with them and talking to different ELN companies, and we are working together to build up this resource so that people can use it. And if people do want to use an ELN, or they want to know what's out there, they want to know it exists, then they can go and have a look at this. And I think that this, and I also want to make a similar tool for generic notebooking software, because again, that's very important, and that might be something that is preferable for people to use. But I think we need to figure out what we actually want to do. As researchers, if we're looking to record our data, we need to figure out what's going on, but also we need awareness of what's out there, what the tools are, and what they can actually do if we're going to make informed decisions. And what I also think is really interesting about this tool is this is the filter criteria that you can currently go between. Obviously, there's quite a lot of nuances to this. There's a lot of different information, but that's quite hard to get on one slide. So this is just the basic top level filter criteria. All the ones coloured in pink relate to things that users have said they care about, they want, and that have come out of either our most recent survey or the one we conducted in case study 6. So it does seem like actually where people are saying, oh, I wish it did this, I wish it did that, I would like it to do this better. This is now actually providing information to go and look up these things. So one of the outcomes of this Pathfinder is going to be a big process recording resource. It will link out to ELN Finder. And also if anyone, I can't actually see who's in the attendees list because I've got my screen up, but if there are any ELN people or you know any ELN people, please give me a shout because I would love to talk to you if you're not featured in the software. And then producing a similar resource for generic notebooking tools, and also looking at what scientific plugins are available for generic notebooking tools, because I also noticed there's quite a lot more chemistry-based plugins for OneNote, for example, that didn't used to exist. So again, clearly that need is slowly being fulfilled. And also putting together best practice guidance on selecting a digital notebook or ELN. But it isn't always just about selecting it. It's also about understanding what's best going to work for your process. So ELNs are sometimes, they can be an answer, and sometimes they're the answer, but other times they're not the answer. But what is the question? I really think that we need to redefine how we think about note-taking in software. There are so many things that need to be taken into consideration if you're choosing a digital solution, and whether that is an ELN, a full digital cloud, a generic notebooking, lots of different software tools. It'd be really nice if this was simple, you just need an ELN, or you just need this, or you just need OneNote, but it's really not. And because of the area I work in, I've had people come up to me frequently and go, oh, what would be your top tip for implementing an ELN? Or I want to implement an ELN, or even I hate ELNs and I want to implement something else, but I don't know what it is. But I think that there's a lot of things we need to consider before implementing these solutions. So, what data are you recording? So if we're talking about taking data straight from paper lab notebooks into an electronic system, what type of data goes into those paper lab notebooks? Is it tables? Is it textual? Is it kind of narrative observations? Is it formal protocols? Is it reactions? How much of the data you're collecting in the laboratory is electronic or ready off machines versus stuff that you're actually writing down and producing essentially yourself in the lab? What are you actually capturing on paper in the first place? And what isn't working? How is it being captured? Where is it being captured? How much of your data do you actually capture in the lab or write down in the lab versus outside the lab? And also, what are the pain points? that if we're going to implement software, if we're going to actually come up with a better process recording solution, why are we doing this? Is it because your work isn't reproducible? Is it because you can't find work? Is it that then because you can't find things, or because you don't know what other people are doing, stuff is getting needlessly repeated? Like, what is the actual problem that you're trying to solve? Because I've definitely spoken to people who say, I want an ELN. And when I've kind of delved deeper with them to understand, what's actually going on, it seems like actually maybe a different type of solution would be better. And I feel like we're kind of labouring under a lot of misconceptions about quite a few different things, which I'm going to go into over the next few slides, because I feel like people both think that ELNs are the problem and the solution, and that there isn't necessarily any other solution. And yet there's lots of options. There's lots of other scientific types of software out there. It might be that actually something that manages your scientific data better, or some of those nice data analysis workflow programs, even just implemented with OneNote, would actually do what you want. But equally, it might be that there's an ELN or indeed a whole digital research platform out there that would actually overhaul how you do things, if you're willing to do so, and if you're willing to potentially either pay for it, or if it's a free one, adopt it and get people to use it. There's lots of different options, and we want to be recording our data, but ultimately the main aim is having data somewhere that we can find it, use it, it's useful, other people can find it and use it, and ultimately replicate what we've done. We need to be able to go back and look at our past stuff and understand what we've done. Other people need to be able to understand what we've done. That's the main goal. And I feel like sometimes we get a little bit lost in the middle without maybe thinking about where we need to go. So research that we have also been undertaking alongside this is we're working with Pathfinder 3 and Data Revival. So Data Revival extracts is a service to extract information out of essentially paper lab books that have been scanned in. So this is just a little example of how some of the information can be broken up. As you can see, it's been split into page numbers, dates, equation, molecules, tables, text, diagrams, which I think also just highlights the kind of, this is just potentially a typical lab book page, and this sort of highlights the diversity of some of the information you could end up with in a lab book. And we have a lot of University of Southampton lab books that they've given us access to. So we've been given about 4,000, which I have to say I was not best pleased when some of those turned up in our, I think neither Nicky or I were best pleased, and some of them physically turned up in our office and were taking up space. But we have taken and digitized only 635 so far, because it's actually taken a very long time for the library's been helping us with this project, and it's taken them quite a long time to digitize these 635 lab books, which has been about 25,000 pages. This does also lead into questionable storage issues. So Pathfinder 3 is working a lot more on actually the machine learning algorithms to do this, to get everything together, and just the table, and this is just a rough, well, it's not rough, it's the results, but it's just to give you a rough idea of all the different parts of information that have been captured out of those lab book pages. But they're going to share that data with us, because what I really want to understand from this is, firstly, I want to try and link through lab books with supplementary information, thesis and papers, because what I want to understand is what information gets retained across this life cycle. So what gets left behind in the lab book? But of the information that gets left behind in the lab book, what would actually have been useful? And where would it have been useful? And why wasn't this information taken forward? I also think it will be a really useful tool for trying to develop methods for automated metadata extraction, because that's another real issue. Creating metadata is hard and lengthy, and if we can find ways to automate it, then we're much more likely to end up with people actually having metadata with their documents. But this then just kind of led me to the thought, well, even if I had somebody's entire lab book in a digestible form, so I don't know, electronically nicely on my computer, I could search for it, etc., would that be enough? And interestingly, one of the projects that I've been working with Pathfinder 3 to resurrect some data, we had a lot of the information. We had links to their electronic lab notebook, we had their PhD thesis, we had their code, or at least some of the code dumps. We also had on a CD, but at least it wasn't a floppy disk. Even projects that have a lot of information and that you think have been actually quite well documented at the time really aren't, and it still takes quite a lot of work to reproduce what has been done, and you have to make guesswork, there's missing steps. So I don't think it's just about thinking, you know, can we use an electronic notebook, or can we use a generic notebook, or can we make sure everything's digital? It's also, are we recording things in the right way such that people getting hold of this could actually replicate our work? And in a way, that's even more complicated, because I think getting things into an electronic form is one thing, but actually providing the right information to go along that is another. And the more that we work on these things, the more that we look at trying to resurrect data and code. Now, admittedly, I'm coming at this from a more computational angle, because I am a computer scientist and our group does more computational chemistry. But yeah, the more I kind of delve into these, the more complicated it seems. So I think that we really need to dive deeper into this to understand it. I think the resources for process recording and notebooking will be very useful for people that want to use those things, but we also need more information about how we actually put the information into this format so things are going to be reproducible. So on that note, this is just one of the strands of this Pathfinder. When we did the case study 6 work, we identified several different areas. I mean, process recording is kind of the main whole, but I think that there are lots of different areas of research that we also want to do, that we need to do, if we're going to make this work properly. So one of the things we're looking at is integration with software and middleware, because, as I said, electronic lab notebooks can be an answer, but they're not necessarily the only answer. There's lots and lots and lots of scientific software out there. In fact, there's even more scientific software out there than there are ELNs. Naively, innocently, during my PhD, I thought, oh, I wonder, you know, ELNs aside, I wonder how much software is out there for chemists. Now, bear in mind, we're covering the physical sciences. I was literally just thinking about chemistry at this point. Tooled off, had a little look, was quite concerned at how many pieces of software I found, and then went crying to Jeremy because I was like, this is far too much software. How on earth are we going to digest all of this? So there's a lot of different options out there. I think we need people to be able to understand what exists, what they can do, what's the software to do with their data, but also, again, what can be hit by APIs, what's open source, what can be used within academia, but also, are there options for integration? Integration's a big issue. You know, one of the things we often see come back on the surveys and things that we do is, you know, my software doesn't play well together. I think one of the best examples of this was I was in a crystallography lab. I watched somebody take a piece of paper, write down some notes off that piece of paper. It was about their crystal, and then they went over to a machine and they typed in some things, and then they got some numbers off their computer and they wrote them down in a notebook, and then they walked over to a different computer in their office and typed those numbers in. And I was just like, what on earth are you doing? Why isn't there some sort of nice mechanism for putting the data between those two places? And they just said, our software doesn't integrate. So I think we need to look at this from two levels: better software integration, but also where there's the scope for plugins with generic notebooking software. And, you know, on the kind of community recommendation side of things, one of the things that came out of our publication is that we think it's really important for software developers to provide API access, and that there should be facilitation for integration with generic tools. I mean, one of the ELNs that I've seen that I was really, really impressed with is RSpace, because they allow so many different integrations, and you can integrate with things like Google Docs, you can integrate with existing tools that people like and know how to use, like ChemDraw. You know, those things are really important. We shouldn't always be looking to reinvent the wheel. If there's a piece of software that does what we need, let's make that work with other things. Let's not go, oh, we need to make our own version of that. But in order for that to happen, then there does need to be some cooperation on the software side of things. But then, talking of interoperability, this also leads on to data standards and formats. So there's so many different data standards and formats across the physical sciences. So one of the other pieces of work we are currently doing is we have been looking at all the different data formats and data converters. And we're putting together a resource. So current demo in progress screenshot on this slide. But it's basically a resource to help researchers easily locate the best tools and understand, you know, I want to convert between X and Y. Is this possible? What's the quality of the conversion? And where can I go and find that information? because again, I think there's actually a lot of good pieces of software and a lot of good resources around our community, but we're missing that kind of puzzle piece that puts them all together in one place and makes them easy to find. But again, from a community perspective, it's really important to identify areas and disciplines where data format conversion is required. So something you can also do in this tool that we're putting together is, if your conversion doesn't exist, so if you say, oh, I want to convert between X and Y, and it's not there, you can then feed that back, because then that logs to us, oh, actually, clearly somebody needed this and there isn't a converter to do it. And I think there should be a consideration of setting up centralized bodies where they're, where they lack those bodies for the data standards. Metadata is a huge thing. So we're looking at existing metadata standards and catalogs and schemas on ontologies, and we want to identify the best practices for metadata capture in different domains. Also very much want to look at metadata suggester tools. So starting kind of quite early from something that's quite manual in terms of suggesting, so just you might need to put all these things in, to actually trying to extract the metadata out itself. I think the lab notebook data that we're getting could be quite useful for that as a corpus of data to trial that with. But from a community perspective, we also think that it's really important to work together to agree on best practice guidelines for metadata capture. And that software developers should expose what metadata is and isn't automatically captured by their tools. I think metadata is a really wide-ranging and complex area. And again, as I said, the more I've kind of worked with, we've done quite a bit of work alongside Pathfinder 3 of kind of resurrect legacy data sets and looking at older projects and trying to understand what's been done. And it's just, there's just such a wide scope of what needs to be captured. And it's not enough just to have basic information about the data. There needs to be information, how did this data come into play, what's gone on, you need general metadata, you need domain specific metadata, we need to be using consistent terminology, which is where obviously ontologies and schemas come in, but there also needs to be, I guess, further narrative information around that. And not all of that will necessarily be in metadata, but there needs to be signposting alongside when you package up your data to actually show people how on earth you used it and what you were doing in the first place. I mean, part and parcel with that is semantic web enrichment. So we're going to be looking at evaluating relevant ontologies and semantic systems. So again, we have a problem. There's a lot of ontologies, some better known than others. We have been discussing whether it would be useful or not to have an ontology lookup service as a way to find these ontologies. And that is work in progress. And also, we need to understand where there are gaps. I mean, again, there's always a kind of problem of so many people decide to make their own ontologies. Lots of projects almost start and end at the ontology level, which means developers haven't entirely necessarily considered the best use cases for their ontologies or the actual logistics of marking up data using them. And some just are quite hard to find. I mean, I had a conversation with a young student the other day who said, I want to make an ontology. Okay, well, why do you want to make an ontology? Oh, I want to mark up my data, in this way, and I want to do this. Okay, well, would any of these ontologies work? Sent across a bunch. Seemed like some of them at least had quite a lot of overlaps, but they couldn't necessarily find them or know they, didn't necessarily know they existed. There were some I found in papers that I thought, oh, this looks relevant, but heaven knows where the actual ontology is. So we maybe not necessarily an ontology lookup service, perhaps an ontology lookup service, but we do need something that enables us to find out where these ontologies are. We need to understand where there are clear gaps. And also, again, alongside with this comes with looking at the semantic annotation and automated metadata capture. But from a community recommendation perspective, it is really important to maintain your ontologies and to log when they've been maintained, or they should be looked after by a centralized service. And similarly, the lookup services need to be regularly maintained. I mean, if I want to use an ontology, depending on what it is and what it's about, I would like to think I'm using something that's actually up to date and someone's, even not, if not actively developing it, still is at least looking after it. But I also think there needs to be lightweight methods of incorporating semantic web technologies into services. Knowledge graphs are great, but not everything needs to be a knowledge graph. But I mean, I could literally, in fact, I'm sure this will be another webinar, I could just talk about the semantic side of things for multiple hours. But I think I am possibly right. Don't worry, Nikki, I've only got 4 slides left. And the final one is hybrid and voice technology. So I really want to evaluate where some of these technologies could fit into the lab. So, I mean, the thing is with voice, I think there's a lot of use for voice. You know, we have smart homes, why not smart labs? I can see a lot of useful things in terms of, you know, you're somewhere, I'll read out this next stage of the protocol to me, or, oh, I want to understand, or asking a question, operating certain things in a not dangerous fashion. But when we look at those lab books, if we can go back to picturing the lab book that we saw, I do struggle to see how some of those things could be dictated in quite the same way. And then there's going to be issues around pictures, tables, and such like. So I think voice has a place in the lab of the future, but we need to figure out what place. And again, electronic lab notebooks differ quite wildly in terms of their input mechanisms. So some literally start with a chemical reaction. You put in your chemical reaction and you go from there. I don't think that really narrates to voice very well. Whereas others, where you have your protocols, and you know, for example, our space has a integration with Elementor, and you can literally go through and it'll read out every step of your protocol to you, and you can write something back. You know, that seems like a really good use case for voice, but certain other mechanisms don't. So we need to think about where it's going to be useful to add that, and also where I guess just voice assistance in general can come in. But then I think also the hybrid notebook tools, so the things where you've either got smart paper or you've got tablets, that's then going to come in for some of those bits of the lab book that I think we couldn't get those in with voice, but also you can't necessarily get them in with a keyboard. And you have, again, have that painful entry issue if you've got a keyboard. So can we make things work with things that are still electronic, but mirror some of the features of paper that we still like? And again, community recommendations, I think it's really worth anyone working on lab management software looking at those different entry points and whether hybrid devices and voice can have a place there. So these are just relevant publications. So the bottom one is the one that came out of our case study 6, but these are all things our group has published about electronic lab notebooks and metadata, ontologies and such like. And then just want to acknowledge, as ever, probably going to be acknowledging them for the rest of my life, my lovely PhD supervisors, Jeremy and Nick, all the people I've worked on with the electronic lab notebook research, PSDI team, the data revival team, and of course the ELN Finder team, who very kindly have allowed me to come and collaborate on behalf of PSDI. And just lead on to hear our details and any questions.
Thank you very much, Sammy. That was a wonderful presentation, and I'm sure you'll be back to talk further about some of your pet topics of sort of semantics and metadata in the future. It would definitely be a topic that could be a whole webinar by itself. So yes, we'd just like to invite any questions from anybody in the audience around process recording.
One, in your ELN survey, was there a tendency towards web-based versus desktop app? So it's not something we've specifically asked in this survey, but in previous research I've done, yes. Generally, people tend to prefer web-based, and I will say that some of the ELNs that didn't survive between the two time periods I was looking at were the more desktop-based one. There's a lot to be said for browser-based, and quite a lot of people like that nowadays because it means they can use it from any device and everything's being stored in the cloud. There are some caveats to that, in that some people get quite touchy about the idea of cloud storage in terms of trust. So if you've got groups that, you know, we have spoken to some groups who are very kind of conservative and concerned about security, and then they actually don't want to use an ELN at all if it's putting things in the cloud, because they're really worried about their data getting hacked or things not being secure. And actually one of the filter criteria it's been quite diverse when I've been talking to different ELN companies on ELN Finder is the security offerings of the system. There's also occasionally, and I think this is much more of a university issue than a industry-based issue, but there are definitely some slightly more archaic labs that have older machines that don't necessarily have Wi-Fi, don't necessarily have internet, because they're running really old operating systems. So again, if we're going with the logic that you'd be using ELNs on your own devices, as long as the lab had decent Wi-Fi, that would be fine. But if you were trying to use them on lab devices, that wouldn't always work. But also, yes, internet access then tends to be a slight issue there.
I was wondering, kind of almost in terms of like almost like process the recording and stuff, are there any kind of, you know, almost like quick wins that you'd say in terms of maybe potentially improving process recording, when maybe that's either on an individual researcher level or something that you think could improve it on an overall level? Any sort of quick things that people could do?
Thing is, I've advised people on quick wins, but they're often quite bespoke. I think, I mean, to me, the best thing you can do is identifying your top pain point and what could you do to fix it. So sometimes, I mean, so for example, when I was doing my PhD research, something that one of the researchers said to me was, I just wish everything could be in one place. And I was like, but you could put that in one place. You could have, I was like, do you have files on the supercomputer? Do you have files in other places? And they're like, no. So like, well, in that case, you could have a sensible folder structure and sensible file structure where you could actually have all of your research in one place. And yes, I mean, sometimes there's going to be, I guess the big thing is you might have code in GitHub, whereas you'll have your document somewhere else. But you could still have a central place where you would state where your things are. I also think having a document or a record or a something, or the wiki or whatever, that actually states where everything is in the project is really useful.
Yeah, I think definitely from some recent stuff that we've done in terms of training and just implementation of other people, and then trying to catch on with their stuff in terms of reproducibility, that description of like, okay, well, this is my system and this is therefore how the stuff works is like vital, because they might know where it is, but then they'll forget about it very quickly. So we have got a couple more questions come in.
Oh yes, so labs can often be a multi-person environment, so is audio a bit of a non-starter, i.e. disturbing other people in the lab? Yes, that can be another issue. Some of the lab companies have been developing different solutions to go alongside that by having headsets. So you don't necessarily hear the responses from a system that weren't meant for you. And they also deal with some of the noise cancelling issues in terms of obviously audio interference for a system itself. Yes, it might be disturbing in terms of a person talking into a device, although I suppose it also depends how talkative or silent your lab is in the first place. Because if you already talk between yourselves, you know, me saying to Nikki, could you pass me XYZ, and me saying to, I don't know, Alexa, what's the next stage in my protocol? I'm not sure there's a wild amount of difference, but if you were hearing all the feedback and all the XYZ, that would be quite a pain. But I think, again, as with every bit of software and everything, it would probably need to be considered on a lab by lab basis and what people were happy to do. Do you have stats on acceptance rates and the time it takes to implement ELNs in labs? I don't have any specific stats. I will say, again, I think it's always going to be different. It really is very much going to depend on how big the lab is, how much of the processes you're trying to overhaul with the ELN. So are you, for example, are you replacing an existing bit of software? Are you replacing a digital method of doing this? Are you replacing paper? How much are, I mean, in terms of acceptance rates, sometimes people can struggle quite heavily with that. If you're lucky and you have some early adopters and you have people who are interested in that, then fantastic. But one of the big issues is the adoption barriers, and sometimes it can be a bit of a spiral, like a couple of people adopt it and then people start seeing that they're doing it and then it gets better, and other times you get a lot more resistance to it, or people are unwilling to do it because everybody else isn't doing it. There are actually quite a lot of people that specifically work on things like change management and adoption in these areas that will come into companies and try and help them implement these things. But I also think that, again, all those kind of early questions that we talked about are quite important, because, again, if you can identify people's pain points and you can find some of those quick wins in a system to help them, you're going to bring them on a lot better. But unfortunately, it is quite lab bespoke. Headset running for several hours at a stretch will probably be unpopular. Yeah, that's completely fair enough. I think it depends what you're doing in the lab. As I said, voice won't fit for everything. You also wouldn't necessarily, you could use it for interaction with an ELN if you wanted to, but you could also have the notion of just a smart lab in general. So Nikki and I worked on a smart lab system where you could also talk to the lab from outside of the lab to find out bits of information when you were doing something. And I think that, again, if we're going down the route of smart labs, we could have smart labs that do other things that aren't just voice. So you could have message-based systems to alert you, for example, that something has gone wrong and you need to go sort it out. I think there's a lot of different options with these technologies. I think voice has a place, but depending on the lab and depending on the science and the people, we need to find its place.
Yeah, I think one of the things that was quite interesting was that with that work that we did in the past was where you could like layer different systems on top. So you could integrate stuff like potentially like Slack or email or things like that, a web interface or something where you could like respond to it. And then obviously the next level of doing that is that the recording, the control, all sorts of things like on top of that. But once you've kind of structured it in that way that you have it described, it's much easier to layer additional interaction methods on top, whereas obviously when it's just completely free form, you don't have anywhere to start.
I would say thanks for attending the webinar, but also if you are interested in this, then I mean obviously we have our papers, but particularly if you want to talk more about this, feel free to give me a shout. My details should be on the PSDI website. Also, I have a very unique name, so if you just search for Samantha Kanza, it will hit me.